Hi and welcome there. Today we are going to discuss correlation using SPSS. I'm your instructor Rajesh Durbala and I'm an assistant professor in business analytics and research methodology. What's the agenda for today? We are going to discuss a problem. First of all, I'll just give you a basic orientation of what correlation is, and then we'll be discussing a problem and trying to solve it on SPSS. Okay, all set? Let's move ahead and see what's there. So basically what's correlation? Correlation measures the degree of association between two variables. So you need to have two variables in order to find the association between them. For instance, let us say a manager wants to know what is the association or the degree of relationship between the marketing expenditure or the advertising expenditure on sales. Okay, so that could be one study on correlation. So correlation coefficient, which is also represented by the alphabet R, lies between +1 and -1. +1 signifies a high degree of correlation and -1 talks about a negative correlation. 0 stands for almost no correlation. Okay, and this is how we are going to interpret. If R equals to 0, there is no correlation. Okay, if R is less than 0.5, we would say it's a weak positive correlation, and the closer it goes towards 1, it's strong positive, and likewise it's on the other side, on the negative side. That is, the moment we go towards the negative side, we have weak negative correlation or strong negative correlation. Okay, so this is how you can interpret the correlation coefficients. And when I put the data on scatter plots, this is how scatter plots would look at different correlation coefficients. Let us say if I have a correlation coefficient of -0.90, the scatter plots would be sloping downwards from the y-axis to the x-axis. Okay, so these are the various correlation coefficients. You can just pause the video and read them. You can easily understand what it is. If it's -0.9, the data points are falling from the left to the right, and moderate negative correlation, you can see the data points are much dispersed and they are falling downwards. Moderate positive correlation, the data points are dispersed and moving from left to right. Strong positive correlation, you can see the data points are less dispersed and they are moving from left to right. And when the points are all scattered, okay, there's no pattern in them, no correlation at all. Fine, that's quite simple. Let's see and solve a problem. I have a very simple problem. I have a data file which is for Fortune 500 companies from 2005. Okay, now what are we going to find? How strong an association exists between profit and revenue among these companies. I need to know the association between the profit and revenue among these Fortune 500 companies. So how should I do it? Let's see. Let's move ahead and try it out how to solve this problem. Okay, now before solving this problem, I would like to show you how to plot a scatter plot. This is my data. You can see I have already loaded it on SPSS. So there are 500 companies, as it is a Fortune 500 company data. So you can see I have 500 companies. So now first I would like to analyze, just see the pattern of my data, how it looks on a scatter plot. So how do I build a scatter plot? I go to graphs, I go to chart builder, then I come down, I have a gallery of charts. I come to scatter or dot, I select any one of them. So you can see my plot appears. This is the y-axis, this is the x-axis. So I can easily select this. This is just a drag and drop feature. Select the revenue, drop it over here, select the profit and drag it, drop it over here. This is what the question asked me, okay, to find the degree of association between revenue and profit. Now when I'm doing correlation, you don't need to worry about what goes on to the x-axis and what goes on to the y-axis. Okay, this is not at all a problem, so you don't need to worry about it. So this is how I dragged my revenue and profits onto my x and y axis. Okay, I just say okay. This is my SPSS output file. You can see my scatter plot is generated. Okay, now what are the interpretations that I can make out of this output? Okay, you can see all the dots are very closely clustered. Okay, that is the first thing I can see, and as I move upwards, the dots start, you know, loosening up. They are scattered. Okay, this is one thing that I can see. The second thing that I can see is the dots are moving upwards. Okay, so first thing I can say, this is a positive correlation, right? Then secondly, the dots are just clustered over here. Later the dots get spread apart, so I can say it's not highly correlated, but I can say moderately. Okay, so what I expect is this correlation should be not very close to 1, but you can see the density of the points, so definitely it's not even below, I can say it won't be below 50 also, it won't be below 0.5 also. It should be somewhere between it should be somewhere greater than 0.5 and less than obviously 1. Okay, so this is what the interpretation of my points, the scatter plot. Now I'll just see what my correlation coefficient is. Okay, before doing that, let us integrate. I'll just show you how to do some hypothesis testing using your correlation. Okay, let's do some hypothesis testing as well. Now this is my board. Now let us do some hypothesis testing as well. Okay, now let's see. First and foremost, I need to have my null hypothesis. Okay, so my null hypothesis H naught, that would be R is equal to 0. I would try to say that my R equals to 0. Reason being, in my null hypothesis, it should always be equality. I cannot take any inequality as my null hypothesis. And number 2, my null hypothesis is always for probable rejection. Okay, so I frame a hypothesis keeping it in mind that I have to reject it. So since I have seen my scatter plot, there is some degree of association, so I have to reject it. So this is how I frame my null hypothesis. Now my alternate hypothesis would be R is not equal to 0. Okay, that is to say, I don't know whether it's going to be more than 0 or less than 0. Just I have to be ensured that this is less than not equal to 0. So that is very, very important. Now I have my null and alternate hypothesis. Now what next? Next, I assume, let us say, when I get my SPSS output, okay, you have to take care of certain things. Okay, what is your correlation coefficient? That is R. Okay, next I need to know what is my significance. That is what we call the p-value. Okay, this is the p-value. So even I am not aware of this. Okay, so you have to see two very important things. Okay, now just let me show you. Now if I have in my output, let us say my p-value, okay, is less than my alpha. What is alpha? Alpha is my level of significance. Okay, if my p-value is less than alpha, the other condition could be my p-value is greater than alpha. Okay, now if my p-value is less than alpha, that is to say my null hypothesis is rejected. Okay, and if my p-value is greater than alpha, my null hypothesis is accepted. Okay, so this is the decision rule. Now if I just summarize the decision rules, you can understand how it should look like. My p-value greater than, if my p-value is greater than my alpha. Okay, if I'll just write it once again, if my p-value is greater than alpha, okay, then my h naught, that is null hypothesis, gets accepted. Okay, if my p naught is less than alpha, then my h naught gets rejected. So this is what I call my decision rule. Okay, so just remember this, it's going to be very useful. Now let's see, I'll get back to my SPSS. Now let's generate the correlation output. I go to analyze, correlate, I take the bivariate option. Then what are the two options that I'm working on? Two variables, that is, one is revenue, just I take it to this variable box. Then I have my profit for year 2005, I take it there. Okay, I'm interested in the Pearson correlation coefficient, and I take a two-tailed. Okay, I flag the significant correlation, I say okay. Now this is what my correlation matrix looks like. Okay, so my R, that is my correlation coefficient, is 0.679. okay, 0.679, and I see my P, that is the significance value, is 0.000. Great. Now what is my alpha? My alpha is 0.01. So it ended up this way, my alpha is greater than P, or my P is less than alpha. So if my P is less than alpha, my H naught gets rejected. Okay, so here my H naught, that is R equals to 0, that is to say there is no correlation, gets rejected. So through my hypothesis test, I'm able to prove that there is certain degree of correlation between these two variables. Okay, and how much is that? That is 0.679. So the degree of association between these two variables is 0.679. So we have proved it through hypothesis testing as well, right? So I hope you have understood this. Let's get back to our slides. So that was interesting interacting with you. You can get in touch with me on LinkedIn, Facebook, Twitter. You can write to me directly at rajeshdurbala@gmail.com. We also run an organization called Let Peace Proliferate. This is the Facebook page, facebook.com/letppro. This is a war against extremism. We do conduct a lot of online and offline activities. Do get in touch with us, support our cause in any possible way. Do like our page, that's the most important thing. Okay, so it was great talking to you people. So hope to see you soon. Thank you. Bye bye.